Alright, geometry peeps, you're gonna have to brace with me on this one. Ugh. Problems with distance formula. Oh, what's the distance formula, might you ask? First couple weeks. If you're given 2 points, oh boy, x1 and y1. Oops, no comma. Ugh. This one's going to be a rough one. And x2, y2, your distance between these 2 points, which we call d, is the square root of the difference of the x's, so they usually do x2 minus x1 squared, plus y2 minus y1 squared. Now we already discussed why order of operations you have to subtract, then square each of these grouping symbols before you can add, and then square root it. And no, the square root does not distribute through addition. It only undoes squares. So if this was times instead of plus, sure, we could get rid of the squares. But no, that doesn't work because of the plus. So the thing I need you to understand, we are proving parallelograms in the coordinate plane, but I don't want you to graph this. No graphing on x and y axes. And I'll tell you why. Basically, like for example here, I'm just going to draw some quadrilateral. We don't know, and we don't do proofs by it looks like. We have to do the work from the distance formula to show that opposite sides are congruent. So in other words, if you can show that AB is congruent to CD, or in other words, AB equals CD, and if AD equals BC, so if AD equals BC, then it's a parallelogram, because opposite sides being congruent, it's a parallelogram. We are going to use the distance formula for those. Excuse me. Now, we also know parallelogram has opposite sides that are parallel. So if AB is parallel to DC, and if AD is parallel to BC, then it's also a parallelogram. Well, in this case, we're going to use slope formula. And if you had me in Algebra 1, you remember slope is your m for the delta y over delta x, and you need to know the parallel lines have the same slopes. So if you can show that the slope of AB is the same as the slope of DC with the points, and if the slope of AD is equal to BC, then they're parallel, and you have a parallelogram. Okay. Notice for each one of these, you either have to do both pairs with the distance formula, or both pairs with the slope formula, or you can do one pair of opposite sides. You have to show that they're congruent and they're parallel. So basically you're using both formulas. So you're using the distance formula and the slope formula. But you're only doing it between 2 pairs rather than all 4 pairs. Okay, so notice in set 1, problems 1 and 2, we are using method 1. We're using the distance formula. So we basically have to show what the distance, we have to calculate the distance for between points A and B. which is like here. We have to calculate the distance. You can go ahead. I would draw yourself a little diagram. So this is what I mean by no graphing. Just call this points A, B, C, and D. Oh wait, oops, I went, instead of circular order, I went into zigzag order. So A, B, C, D go in circular order. Just draw a diagram. Just draw a quadrilateral. We don't know if it's a parallelogram or not until we do all this stuff. So then we're going to find the distance of DC. I'm just going to put them in opposite pairs. Then we're going to do AD and BC. Okay. If these match, then these sides are congruent. If these match, then these sides are congruent. Okay, so let's start with these 2 points. Yay, fun times. So I'm going to subtract the x's, and frankly, it doesn't matter whether you do the second point minus the first or the first point minus the second. You just have to do the same order with the x's as you do the y's. Well, I guess with the square you don't. But it's the same idea with the slope formula. Subtracting the y's over subtracting the x's, use the same order. So we're going to do 4 minus 2 all squared plus, and then we have negative 7 minus 1 all squared. Okay, let's simplify the grouping symbols by order of operations. So we get 2 squared plus negative 8 squared equals the square root of 4 plus 64. And I'm just going to leave it as the lovely square root of 68. Don't try and simplify it any further. We're good there. Now on a multiple choice test, you might have to factor out a 4 and find out it's 4 times 17, and then it becomes 2 root 17. Here, as long as we can find that the radicals are the same, then we know that the sides are congruent. So let's do it for DC. Or CD, doesn't matter. So let's do these 2 points. So I'm going to do the square root. This is an odd angle for me to write with my lefty. So negative 8 minus negative 6. Don't forget to write in the negative separate from the minus. All squared. I did the y's first. It doesn't matter. I guess I'm getting used to the slope formula. As long as you subtract them, square them, and add them. Okay, now I'm going to do, did I do that for this one too? I did, didn't I? Okay, usually it works out. So then I have 9 minus 1 all squared. Some of you are probably wondering about that. So this becomes negative 8 plus 6 is negative 2 squared. 9 minus 1, 8 squared, all under the radical. So that becomes the square root of 4 plus 64. Heck, we know automatically, since these 2 distances are the same, AB is going to be congruent to DC. Okay. Now let's do it for AD and BC. Can I just tell you? Ugh, fine. Never mind. Let's do it. My favorites. Okay, so we have to do A and D. These for this side. Oh wait, we can mark this now because we showed the distance between each pair of points is congruent. You have to do A and D. Please don't do the incorrect coordinates. So I'm going to start with the x's like the formula says. So negative 7 minus 1 squared plus 4 minus negative 6. So that equals the square root. This is negative 8 squared. And that becomes 10 squared. Well, that's 64 plus 100 under the square root. So that's the square root of 164. Okay, we're just going to stop there. On a multiple choice test, you might need to simplify that. Now let's do BC. Okay, same formula. So 1 minus 9 squared plus 4, wrong point. Yeah, don't make that mistake. BC. So 2 minus negative 8 squared. So this is -8 squared plus, this becomes 10 squared. Well, I already know it's the same because that ends up being the square root of 64 plus 100, which is the square root of 164. And boom, these are congruent. And because we have both pairs of opposite sides that are congruent, we can say, therefore, A, B, C, D is a parallelogram. Okay, boom. You get to do this one on your own. Yay! Okay, now set 2, slope formula. Basically, remember, we want to ultimately show, using slope, that A, B, C, D has two pairs of opposite sides that are parallel. And we know that parallel lines have the same slope. So we're going to use the delta y over delta x. That's the change in y. Or the boring formula is y2 minus y1 over x2 minus x1. Of course, I'm a rebel, and so you can do y1 minus y2 over x1 minus x2 as long as you do it in the same order. So first, I don't want you to graph it, because that's not the point of these. Even though they're giving you points, just draw a quadrilateral. We don't know yet until we do the work if this is a parallelogram or not. So we're going to do the slope of the points. Oh, guess what? I didn't even use, that's a minor detail. Not. Oh, you can tell it's been a long day. Okay. W, is that an X? Oh, yes. Y and Z. So W, X, Y, and Z. Oh, one day, guys, you're going to get to this point. You won't be able to see like me. Whew. Okay, so let's start with the slope of WX. And then we're going to do the slope of ZY because these are opposite sides. Then we're going to do the slope of WZ. And we're going to do the slope of XY. All right, so WX. Do the y's first. I think that's why I was in the habit of doing the y's here first. But with this formula, because addition is commutative, it doesn't matter whether you do the y's, subtracting the y's and then square it first, or subtract the x's and square it next. But with slope, you must do the y's, subtract the y's in the numerator and the x's in the denominator, because the y's are the vertical change and the x's are the horizontal change. That's the whole point of slope. Okay. So we have to do -4 minus -6 over -7 minus 1. And we know subtracting a negative is the same thing as adding a positive. So we have 2 over -8. Oh, I have a hard time. All right, just reduce it. Positive over negative is -3/4. Okay. Ugh, that negative looks like the fraction. Now let's do ZY. Or YZ, doesn't matter. So let's do -13 minus -12 over 5 minus 1. I can already, oh, yeah. This one is not going to work out. So as soon as I see, okay, this is going to be -1 over 4, these are not the same slopes. So that means I can stop. I don't have to do this. Oh, I actually love it when it's not a parallelogram because I don't have to do the other part. So no, WXYZ is not a parallelogram because the slope of WX does not equal the slope of ZY. Boom. Okay. So similar on this side. Let's say you do for PQRS and you find out that PQ is not the same distance as RS. You don't have to do the second half of the problem. Okay. But I'm not saying it is. You still have to do the work and find out if it is. Okay. All right, last one. When you are doing one side using the distance and the slope formula, it doesn't matter which 2 points or which 2 sides you use, but you have to stay consistent. So if I have J, K, L, M, and I'm just going to give you a tip, I would put these 2 together and these 2 together to do the distance formula and the slope formula. So we're going to do the distance formula for JK and LM. Then we're going to do the slope of JK and the slope of LM. Okay. Now if these are equal and these are equal, then it's for sure a parallelogram. Okay. So let's do the distance formula. So I'm going to do -9 minus -5 squared plus -2 minus 1 squared. By the way, if these aren't equal, it's not a parallelogram. So we get the square root. So -9 plus 5, -4 squared. And -2 minus 1, -3 squared. Well, that's the square root of 16 plus 9, which is the square root of 25, which is 5, because that's just easy to simplify. So if we don't get 5 here, it's not a parallelogram. All right. If it is, we have the joy of doing the slopes. It's been a long day, I'm so sorry. Okay. So 1 minus -3 plus -4 minus -7 so we get the square root, well 1 plus 3 is 4 squared, plus -4 plus 7 is 3 squared. Well, I already know square root of 16 plus 9 is going to be the square root of 25, which is 5. So these are equal. So I know that JK is congruent to ML because their distances are the same. Now we have to see if they're parallel as well. So we're going to use the slope. So let's do the y's. So -2 minus 1 over -9 minus -5. So that becomes -3 over, well, -4, which is just 3/4. And LM, so I have -4 minus -7 over 1 minus -3. So we get 3 over 4, and they're the same. So therefore, oops, I almost put ABCD. JKML is a parallelogram because JK is congruent to LM and JK is parallel to LM. And we proved it with our work showing that the distance between each pair of points is the same and the slope of each side is the same. So go ahead and do the evens and then check the answer key.